Hello students, welcome to this class on network layer and transport layer. In the previous classes we discussed what is OSI reference model. It is having 7 layers. The first layer is physical layer, data link layer. About that we already discussed. So this class will be discussing network layer and transport layer. Network layer. The network layer is responsible for delivery of packets from original source to the final destination. So what is the meaning of this? Suppose assume this is a source, this is a network, in this network this is the source, and assume this is what is the destination. Okay, so the network layer is responsible for delivery of packets from original source to the final destination across the network. So network layer receives data from the transport layer, adds headers at the transmitter side, and then give it to the data link layer. Then data link layer will give to the physical layer, then physical layer will transmit to the medium, and at the receiver side the reverse process will take place, and at the network layer it will receive the packets and understand what is this H3. After separating this H3 it will give it to the transport layer. Network layer is responsible for source to destination delivery of packets across multiple networks. For this it needs an additional address which is different from the physical address. So earlier we discussed the data link layer adds a physical address. Okay, the network layer adds one additional address that is called as the logical address. What is logical address? Let us take one example. This is Aditya Rao. We want to send a packet to him. This packet we want to send to Aditya Rao. Now Aditya Rao is having a unique identification. What is the unique identification? You know, this is the Aadhaar card. In India we are having an Aadhaar card, and Aadhaar card, let us say he is having the Aadhaar number is this. So using this Aadhaar number we can identify Aditya. There will be so many Adityas involved, but this unique Aadhaar number will identify Aditya. But using this ID, Aadhaar ID, finding out where is Aditya and delivering this packet will be really difficult. So let us see how we can do it easily. Assume Aditya is studying in BITS Pilani campus. He is studying in staying in Vyas Bhavan, room number 231. Now if I am using this address, the courier person or the postal person can easily deliver this packet to Aditya, right? So here this Aadhaar number is a physical address. We can say this is a physical identification purpose. We are using Aadhaar number, and this one is a logical address of Aditya Rao. So why it is logical? Because the location where Aditya is presently studying, his room number is given here, and this location we can reach logically. So BITS Pilani campus, looking to this room pin code 333031, we can say that okay, this is he is presently at Rajasthan. In Rajasthan, in Pilani the Vyas Bhavan hostel. In Vyas Bhavan, this is the room number. So this address will help us to reach Aditya Rao logically. Now let us assume Aditya Rao has completed his engineering and is going for MS in Princeton University. Okay, so now Aditya Rao is moving from BITS Pilani to Princeton University. His physical address will be remaining same. That's the Aadhaar number will be remaining same. What will change? His logical address will change. When he is moving from BITS Pilani to Princeton University, his logical address will change. So that's how you can see this is the new address of Aditya Rao, right? So what is happening? This is the logical address. The logical address will help us to reach to the specific location logical way. We can find out what is which country, which state, which city, which room number, which house. All these things will be available in the logical address. But the physical address will not give a logical approach of reaching to the students. Okay, using this physical address to reach to the student will be extremely difficult. But if we have a very few number of people, let us say in a class of 30 students, and we are going to there and finding out who is Aditya, and we can identify using this specific Aadhaar number, no problem, that is fine. But using in throughout the world, if you want to reach Aditya using Aadhaar number, it will be extremely impossible. So we have to use a logical address, right? So that is why we need two addresses. One thing is a physical address, another thing is the logical address. In our computers, a laptop, whatever I am using, if I am presently using my laptop in BITS Pilani campus, my logical address or the IP address is provided by BITS Pilani. If I am moving from BITS Pilani to Princeton University, there my IP address will be different, the logical address will be different. So that will be provided by Princeton University network administrator. My physical address for my laptop, that is provided by the LAN card or network interface card, will be remaining same. Whether I am using it inside BITS Pilani campus or I am going to Princeton University, the physical address will be same. Understood what is the difference between logical address and physical address? Let us discuss something more related to logical address. This is an universal address which remains same from original to final destination. So this will be remaining same when we are transferring a packet from source to the destination. So the destination address is the logical address, that will be remaining same. Let us take the same example. Now from BITS Hyderabad, I am sending a letter. This is a letter to our friend Aditya Rao. So to send it, what I have to do, so here I shall put the address as this. Looking to this address, after writing this address on the envelope here, what I shall do, I shall post it in the Hakimpet post office. This is nearby BITS Hyderabad campus. Now this will go to Hyderabad main post office. Okay. Then this will go to, so when it will reach at Hyderabad post office, main post office, this Hyderabad main post office person will see what is the destination address. Okay, this is BITS Pilani campus 333031. It is in Rajasthan. So what they will do, they will transfer it to Rajasthan main post office. Okay, Rajasthan, maybe Jaipur. Okay, in Rajasthan it is Jaipur, that's the Jaipur. From Jaipur, they will send it to Pilani post office. How they will send? They will look to this logical address. You see, every place in Hakimpet also, you will look what is the destination address. This is the destination address, Pilani. In Hyderabad main post office, they also will see this logical address. In Rajasthan, Jaipur, they will also look into this address. In Pilani also, they will look into this address. And finally, they will deliver it to to Aditya Rao. Okay, so that is how, when this is an universal address which remains same from origin to final destination at the time of transmitting the packet, at the time of transmitting the letter. So as long as Aditya Rao is here and we have initiated a process of transmitting a letter, so in the letter, whatever the logical address is given, looking to that, the packets will move from one node to the one post office to the next post office, the next one, and the next, and finally it will reach the destination. Okay. So this is an universal address which remains same from original to final destinations. But what is changing here is, when it is reaching at Hakimpet, it will see, okay, what is the next? It is the Hyderabad main post office. When it will reach at Hyderabad main post office, it will find out, looking to the logical address, it will find out what is the next. Okay, this is to the Rajasthan, Jaipur. In Jaipur, it will find out what is the next. It is the Pilani post office. So every time the logical address is remaining same, but the next next address is changing. Okay. Let us take one example. A want to send data to P, which is present outside the network. You can see this is consisting of three networks. This is the first network, this is the second network, this is the third network. And these are connected through two routers. This is one router, this is another router. Okay. So the data packet along with the physical and logical address at input and output of each node. So this is one node. From here to here it will come. Second node, from this point to this point it will come. From this point to this point it will come. Right. So what we have to find out, what will be the physical and logical address here, what will be the physical and logical address here, what will be the physical and logical address here for the packet. Let us see. So here, if you look to the packet, in this the logical source is A, destination is P, and the physical address is 10, and here it is 20. Okay, 20, 10 and 20. Now when this packet is moving out of this router, here this will have same logical address will be same, A and P. Source address is A, destination address is P, but the physical address will change as 99 to 33. Because this router will understand, looking to this destination, it will understand that, oh, this destination is not belonging to this place. Okay, this will have to move to this one. This will come to this router. Okay. Now when it will come out from this router, what will be the things? So it will be having same logical addresses. The source address is A, the destination address is B, and the physical address will be 86 and 95. Okay, you can see here the logical addresses are remaining same, but the physical address is changing across nodes. When in the beginning it was 1020, here it is 9933, now here it is 86 and 95. Logical address is allocated dynamically to user as he joins the network. When I am present in BITS Pilani campus, I shall be allocated a logical address by the BITS Pilani network. If I am going to Princeton University with my laptop, I shall be allocated an IP address by the Princeton University network, and their IP address will be different. Okay, next layer is the transport layer. The transport layer is responsible for delivery of message from one process to another. Okay, here two things are written. One is a message, another is a process to one process to another. From which layer transport layer gets data? Transport layer gets data from the upper layer, session layer, right? And which layer it will give to the transport layer will give the data? It will give to the next lower layer, that is the network layer, which we discussed. What is message delivery and how it is different from the packet delivery? A message, assume a message is a large size of to be transmitted is 90 MB. I want to transmit a message of 90 MB. But the network may not be suitable to transmit such a large message. So what it will do, it may break this 90 MB message into 3 30 MB messages. Okay, so those 3 30 MB messages will make 3 packets. So combination of 3 packets will be giving me a message. Message is to be divided into a transmittable segment called as the packets. As if a message is larger, we cannot transmit the complete large message across the network at a time. So what we have to do, we have to break that message into number of packets, transmittable segments, and then transmit one after another. So when we transmit this, each packet may travel in different path in network, so may arrive out of sequence in its sequence numbers. So let us see what is happening here. This is source, this is what is the destination, B is the destination. So we are having 3 packets, P1, P2, P3, 3 packets, okay, but this is corresponding to a single message. Now what is happening? So packet 1 is going through this path. You can see here, this is going through this path. Packet 2 is also following this, but packet 3 is finding out that, oh, this path is already occupied, it is busy, so let me transmit through this path. So it is transmitting through this path and finally reach here. Now it may happen that this path is free, so packet 3 will reach speedily. So it may happen that P1 will reach, then P3 will reach, then P2 will reach. Okay, so what destination will do? If it will receive P1, P3, P2 as it is, then it will not be correct. It has to do sequencing. So it will first use P1, then it will keep P2, then it will keep P3. So proper sequencing is to be done. So for doing this sequencing, what is required? At the transmitter end, when we are making this into number of packets, each packet should be given the packet number. Okay, so that using this packet number at the receiver end, even if these packets are received randomly in a different order, we can sequence it and give it to the destination properly. So that is one of the job of transport layer. So transport layer, from upper layer it is receiving, maybe we'll see from upper layer it is receiving, it is breaking into 3 segments. It can be more number of segments. In this case we have taken 3 segments, and each segment it will add headers, okay, and then give it to the network layer, and the receiver side, the reverse process takes place. So segmentation and reassembling is job of transport layer. At the transmitter side, a message is divided into transmittable segments. Each segment contains a sequence number, as we discussed. This sequence number helps to reassemble the message at the receiver. So these 3 packets are received at the receiver end. Using the sequence number, those packets will be reassembled at the receiver. The transport layer is responsible for delivery of messages from one process to another. What is the meaning of process? See, when you are using internet, you are browsing something, you can browse, you can open number of tabs, and in each tab you can open different applications. Sometimes you may browse email, sometimes you may browse cricket. So each of them is one process. To identify this process, we use an address that is called the port address. So port address. Transport layer adds an address called as service point address or port address along with each packet, so that the packet will go to the specific program or process. So let us see, in internet I have one tab is I am using email. The other tab is I am doing for online shopping using Amazon. Other tab I am using surfing something in Stanford University. Then another place is I am watching IPL. So in all these four tabs, each whatever I am clicking, if I am clicking on to know the descent scores, whatever I shall click, according to that, packets will be received. Packet will be received and will come to my computer. After coming to my computer, how? The computer will know where to send, whether I have to send it to here, to here, to here, to here, which one I have to send. To identify that, these are the four processes. To identify those processes, we use the address called as the port address. That's what we discussed, right? So using that specific address, the packet will come to this specific process. So we have three addresses. One is the physical address, second is the logical address. Using the logical address, the packet will come to my computer, to my destination or to my computer. After coming to my computer, which process it will go, whether to Stanford University, to a website, or to go to the IPL, or to Amazon Shopping, or to email, that depends on the specific port number. So some more functions done by transport layer are error control and flow control. So data link layer also performs error control and flow control. What is the difference? It is here the flow control and error control is done for end-to-end, process to process, rather than across a single link as is done the data link layer. So if you see, this is my source, this is my destination. So when we are transmitting a message from source to this destination, it can be broken into number of packets and can be transmitted. So for every packet, from one hub to the other hub, the checking of error control and flow control is done by the data link layer. But from the end, this end to the other end is taken care by the transport layer. So transport layer performs error control and flow control for end-to-end, process to process, rather than across single link. So across single link means this is across single link is done by the data link layer. Some other function of transport layer is connection control. Data transmission can be done in two ways. One is a connection layer, in which each segment behaves as an independent packet and can follow any path. So transport layer takes care of rearranging the packets at the destinations. So another is the connection oriented. A connection is first established before data transmission and all segments follow same path. Transport layer is responsible for establishing the connection. So let us say this is the case of connection layer. So what happens, we are having a message. This message is divided into P1, P2, P3, three packets. These three packets are traveling in different path and will be reaching here. So in connectionless communication, all these three packets will travel in different path and reach here. Let be P1, P3, P2. Okay. And what is to be done? They need to be arranged to make it P1, P2, P3 using the sequence number. In connection oriented communication, what is done? Before transmission itself, a path is established. A path is set, okay, all the packets have to follow this path. So now what will happen? P1, P2, P3, all three packets will follow this route and will reach here. So P1, P2, P3. So here they will reach in the same sequence as they are transmitted, because they are following the same path. One after another will transfer and will reach here. Okay. Let us take one example. You people are coming for there is a function in our BITS campus, and here maybe very big function, maybe convocation is there, and we are requesting Modi ji to come. Modi ji has accepted invitation and assume he is coming. Just for example, I am telling. Now when Modi ji will come, for him coming from airport to this place, they all administration will take care which path he will follow to reach from airport to BITS campus. Okay, and the path will be fast. The path will be decided. Modi ji along with all his other ministers will follow the same path and reach at BITS campus. Okay, but assume there are many other people will be there who are not that much important. So then what happens? They may reach at the airport and they may follow different path and reach at the destinations. So what will be the advantage in case of Modi ji? He don't have to search for the route. He will follow a path which is predefined, and on that path he will come and reach the destination. But in case of other people, general people, what will happen? They have to find out the path, which route will be good, which route will not be good. On the path they may miss the proper route, they may go in a different way and finally reach here. So it will take more time, right? So when we have to transmit many large number of packets from one source to the final destination, in such case we may go for connection oriented communication. But if we have only few packets, in that case we may go for connectionless communication. So that depends what is in. Again, connectionless is also having advantage. One advantage is that if we are finding out that this path is getting busy, traffic is more, then we can send some packets here. which is not possible in case of connection-oriented communications. Some examples of connectionless is protocols are user datagram protocol is a connection-less protocol, whereas transmission control protocol, TCP protocol, is a connection-oriented protocol. So with this we understood the two layers. One is the network layer, basic function of network layer. Network layer provides a logical address. Then we discuss the transport layer. Transport layer provides transfer of message from one process to other process. Along with that, it also takes care of error control, flow control, connectionless as connection-oriented transmissions. We'll discuss the other three layers in the next class.